Hi and welcome in today's lesson. And today's lesson has something to do about physical quantities. And physical quantities are, well, the definition of the word quantities has something to do about the measurement of things that we have inside the laboratory, or not even inside the laboratory, but around us that can be physically measured. So, for example, we have two types of quantities. The first one is what we call the scalar quantities, and then the second one is the vector quantity. We will go over the specific of scalar and vector quantities as we move on to the succeeding page. But at this moment, let us just talk about the ways we measure the quantities itself. Quantities can either be mass or the amount of substance that we want to measure. Now there's different types of measurement. We have what we call the direct measurement, and the other one is indirect measurement, where indirect measurement would later on apply our skills in mathematics, such as figuring out the slopes, or at the same time figuring out the area of a certain graph. Now, talk about System International, or also known as SI system, or the International Unit of Measurement as it's specified over here. It's actually in French. It's Le Système International, the units. And as I'm mentioning this, okay, through here, there's if you are in your math class, most of the measurement in terms of, let's say, dimensional measurement of, let's say, the length of this certain line, it is measured in terms of inches. When it's a little bit longer, we use rulers, that is a foot. If it's more than a foot, sometimes we use yards into what we call miles. Now, the United States is one of the country, the so-called most powerful country in the world, however, is still stuck in the past. That's why we still use the imperial system. And that's why in our educational system, most of the students are confused which ones to use. Because in science per se, for example, when you go to NASA, all of its calculation are in metric system. However, when you go to the automotive industry, let's say when you go to Michigan, factories of Ford and General Motors, most of the threads, most of the nuts and bolts are measured in terms of what we call the English system. That's why wrenches are measured in terms of fraction, 1/4 of an inch, 5/16 of an inch. While in metric system, like Japanese cars, where they use the international system of measurement, they use millimeters, they use centimeters, and they also use meters, depending on what dimension you're trying to measure. Now, in our case, MKS, CGS. And the two other countries, before I forget, that still uses the English system, first one is Myanmar, which is formerly known as Burma, one of the poor third world countries in Southeast Asia. And then another one is located in in so-called old Russian Federation, and that is Liberia. Now, MKS and CGS, as if you notice, I have already written something here as annotation. So I want you to write it down. There's two measurement, which is MKS and CGS. So when you go ahead and purchase some textbooks, especially engineering textbook, and it's in metric system, in English system, you have an option to purchase it in MKS or CGS. So now let me explain to you the difference between MKS and CGS. So I want you to read this section of our notes, and what I want you to do is just try to understand why is it and what's the benefit of using the metric system over the English system. Well, first of all, it's divisible by 10, power of 10. So those of you who took Mr. Stemple's class, he went over the power of 10, which is the use of metric system. Now, length. So there are three basic measurements. Okay, and the three basic measurement is specifically mentioned here. First one is length, followed by mass, and then lastly is time. So let me just write it down. Basic quantities to measure. Okay, so these are the things that we measure, basic quantities that we measure. So first one is length. What is the symbol of length? Length stands for something that we measure in terms of length. So L is basically our measure. Make sure that is lowercase l. What are some examples of length? It could either be distance or displacement. But just to be specific, we're talking about symbol, which is L. Symbol is different from unit name. Okay, unit symbol. Sometimes a lot of students are confused with this. So when we talk about symbol, we're talking about the symbol of length, which is L. When we're talking about distance or displacement, then we will use the lowercase d to represent distance. Nomenclature is I would say fancy word of saying symbol. In science, we use some fancy names, especially in engineering, so we use nomenclature. So mass is the next one, which is represented by the letter M. This is the more confusing because some of you might be using lowercase m to represent mass, while it's actually the unit measurement of length, which is m. So we need to be careful with this one. Now, when we talk about time, okay, so when we talk about time, time is always measured in terms of second, and time is represented by lowercase t. So it should be represented by lowercase t. Sometimes time is also known as period. Okay, period. So that's why your t changed into delta t, which is the change in the actual time. The actual time, let's say, you start from 0 and then afterwards you look at the clock, it's already 5 seconds passed, so that's why we have a period of 5 seconds, which is delta t. So 5 minus 0, which the change in the actual time, that will be your period. So looking over again to MKS. MKS. So basically MKS stands for meters, kilograms, and second. Meters, kilogram, second. Okay, so again, meters, kilogram, second. Meters, kilogram, second, that's MKS. Now what if it's smaller? Then let me use a different color pen over here. So if the measurement is a little bit smaller, so instead of using instead of using foot, we will use inches. So therefore, instead of using meters, we will use what we call the cm, which is centimeter. That's where we have the C in RCGS, which is a centimeter. So you divide a certain number, you divide the meters by a certain number to come up with centimeters. So from the word centi means something. Kilogram, instead of using kg, we will just use the representation of g, which is grams. Cg, and then of course seconds is still going to be seconds because that's the smallest unit of time. The smallest unit of time is called the seconds. There are some smaller unit of time, such as sometimes we use it in the Olympics, the most recent Olympic, where you have milliseconds, and that is in terms of 800 or 1,000 of a second. So meaning you have to divide it by a second. So these are the most common unit of measurement that you will encounter in our class, which is Physics of the Universe. And this should be during the first semester all the way to December. Now there are secondary unit of measurement. Well, for example, we have it here, and that is, let me just use the red pen. So to differentiate that, the first section is considered the basic quantities of measurement, and then there's another one that has a little bit complicated to measure. This is more of it. They do exist. Okay, they do exist because of what you've learned in chemistry, that this is the molecular level, activities in the molecular level that you cannot see it using your naked eye. So electric current, what do you think is the symbol for electric current? Some of you might be saying it should be C because that says electric current, ENC. Okay, it's measured in amperes. So therefore, this is what we call letter I, uppercase I. There are a lot of different explanations why we use I. The most common one is called the intensity of the flow of electrons. However, sometime in 1994, when the textbooks were changed, the scientific community changed that it's not the flow of electrons, but instead it's the flow of electricity. Okay, flow of electricity, because the flow of electrons, meaning it is flowing from positive to negative, as you learned it in chemistry class. So some of you might be confused. What are you talking about in terms of representation of the letter I? I is called the intensity of electric current or electric flow, or some would say has something to do about the imaginary flow of electricity. Now this one is a little bit confusing. Okay, so this is a little bit confusing because there's two types of, I would say not two types, but the way we represent temperature. So there's what we call the temperature scale, and in metric system is Celsius. Sometimes it's also known as centigrade, but we're familiar with Fahrenheit. And in chemistry class, you have encountered equations such as the four-sided triangle, which is Q equals mass multiplied by the specific heat at constant temperature multiplied by the change in temperature. So change in temperature, but